I claim that printing TPU on the left nozzle of the H2C is a huge disaster. But some of you disagreed with me in the comments. Apparently, it is possible, so why does Bambu Lab advise against it? It would actually be the ideal configuration for the H2C because it keeps the Vortex system free for true multi-material prints with minimal waste. So you don't have to risk a clogged nozzle. In this video, I'm going to show you how to safely print soft 85A TPU with the H2 series printers and a trick to get even softer prints. This way you save yourself endless testing and get straight to a perfect result. Hi, my name is Niels and you are watching Perspective 3D. And when I tested the H2C, my biggest criticism was that Bambu Lab only recommends printing TPU with the right nozzle. But that blocks the Vortex system, which makes absolutely no sense. Why doesn't Bambu Lab want us using the left nozzle for TPU, even though it's the logical configuration? The reason is simple. Soft TPU behaves kind of like cooked spaghetti. It has no stability when the extruder motor pushes it into the hot end. And that's why for TPU, it is crucial that the filament path is as short and low friction as possible. And that is exactly the problem with the H2D and H2C. The left hot end isn't rigid. It has to constantly lift and lower to switch between the right and left nozzles. The result is simply a significantly longer filament path. And on a longer path, more can go wrong. To successfully print TPU on the left nozzle, we can't change the printhead hardware, but we can optimize the feeding. The standard path through the AMS and filament buffer is way too long for soft material anyway, so you generally have to feed TPU directly via the bypass to the printhead. And to reduce the resistance even further, I'm using a setup from the Bambu Lab wiki for this test, where the spool is positioned directly above the printer using a printed holder. The key here is skipping the PTFE tube entirely and basically letting the filament run freely from above into the extruder. This gives us the shortest possible feed path and reduces friction to an absolute minimum. However, you still can't print TPU on the left nozzle with this setup alone, because Bambu Lab throws software roadblocks in your way. So we need to use a trick. Bambu Lab does allow TPU on the left nozzle, but only their own TPU for AMS, which is relatively hard and doesn't cause issues. So we simply select that profile and that allows us to load the softer TPU from our spool holder. But now we have a different problem. The print settings for TPU for AMS don't match softer TPU, so the next step is to create your own profiles. For this video, Siraya Tech kindly provided a range of TPU filaments in different hardness levels for free. I first discovered and fell in love with Siraya Tech filament in my video about PEBA filament. Not only is the quality great, but Siraya also offers optimized profiles for download on their website. This makes setting up your own profiles really easy. I just have to create a custom filament based on the TPU for AMS and then simply copy over all the settings, temperature, retraction and so on from the Siraya profile. Now we have the right settings for the different TPUs and the H2C stops complaining when we want to load TPU on the left nozzle. For the first attempt, I'm testing TPU in 3 different hardness levels using the so-called retraction test. This consists of 2 cylinders on a base where layers are printed alternately left and right. In between, meaning when the printhead travels between the 2 cylinders, the filament is pulled back briefly to prevent it from oozing out of the nozzle. And this is exactly the critical part for TPU, since it can get tangled or jammed in the extruder. TPU comes in different hardness levels and generally, the harder it is, the easier it is to print. To avoid starting with a fail right away, I started with the relatively stiff TPU 64D and then switched to the softer TPU 95A. Since that worked well too, I finally dared to try the TPU 85A. And what can I say? As you can see, although the stringing, meaning the threads between the 2 cylinders, gets worse the softer the TPU is, there were no clogs or any other issues. That surprised me because it really seems like printing soft TPU on the left nozzle of the H2C is not a problem at all. Or maybe I just picked the wrong test? Because the actually critical case for the H2C might be less about retraction and more about nozzle swap between the left and right sides. For example, when I combine multiple PLAs with TPU. So I quickly built my own test in the slicer. Simply 2 cylinders, one made of TPU printed with the left nozzle and the other made of PLA printed with the right nozzle. This forces over 150 swaps during the tests, and in my view, that is the absolute worst case scenario for TPU on the H2C, where theoretically problems should happen. Encouraged by the first success, I decided to go for it and started immediately with the soft TPU 85A. And after 1 hour, 34 minutes and 500 changes, it was clear. No problems here either. No clogged nozzles, just a completely trouble-free print. And that made me wonder a bit, why does Bambu Lab artificially limit the H2C here? Aside from this, the H2C is one of the most versatile 3D printers and for me, currently the ultimate all-rounder, as I showed in my review. I can only speculate if Bambu Lab maybe changed something in the extruder hardware for the H2C, because Bambu Lab promises official support for TPU on the left nozzle via a software update in the wiki for the H2C, but not for the H2D. Anyway, the result is clear to me. With a little effort, even soft TPU down to 85A hardness is actually no problem on the H2C. And if you need even softer prints, I will tell you a trick. Siraya also sent me a spool of their TPU Air, and this lets you achieve really soft prints down to 65A. The filament is actually relatively stiff before printing, but contains active components that foam up due to the temperature in the nozzle. This makes it much softer after printing, and the coolest part is that you can actually adjust the hardness from about 82A down to 65A just by changing the print temperature. I didn't want to keep this from you, and in the first test the filament looks really promising. I will make a separate video about that, and to make sure you don't miss it, feel free to leave a sub and a thumbs up. Thanks for watching and for the support, and if you haven't had enough of 3D printing and filaments yet, definitely check out these 2 videos here.